Hello students, this is lecture number 2 for probability, and in the previous lecture I told you there are two types of probability. One is empirical probability and second one is classical probability. So in this lecture we will talk about only empirical probability. What is the empirical probability? Empirical probability, if you read it, it is generally predict on the past activities. We predict the future. Clear? So if you see, it is a probability calculated by collecting data from the past trials. Clear? Of the experiment, and it is used to predict the future of the event occurring. Clear? Like there are many examples we can have for this one. If say we are going to Muscat International Airport, clear, and if we are having, say I'm going to say Dubai, clear, by the evening 6 p.m. flight. If this flight is continuously unstable, means delayed, sometimes it is right time, sometimes it is delayed, clear, for the past 1 month, and if you ask me what is the status of flight, then immediately I will say I cannot say about this flight. Because why I cannot say? Because the past experience, past response of the flight is not good. Clear? So I will predict the future behavior. It may be delayed because in the past it was delayed many times. The second example is on the basis of our experience, we predict the performance of an automobile. Clear? Say we everyone have car. Okay, and my father wants to buy a new car. Immediately what we will say? Oh, Nissan cars are good, or Toyota cars are good, or no, Chevrolet cars are good. How we call it? It we call it on our experience. Experience means from the past trials. We bought a Nissan car and it was performing good, so we will say that it is good. So we are predicting future. Clear? So these type of probabilities we discuss in this empirical probability. Clear? What is the formula for this? It is let there will be n trials. There will be n trials of an experiment. There will be n trials of an experiment. Clear? And A is an event associated to it. Associated to it, such that A happens in M trials. A happens in M trials. Then the empirical probability happening of event A is denoted by PA. Clear? And is given by how we do it? PA equals to M upon N. Clear? M upon n. M upon n means what is M? Number of trials. Number of trials in which event happened upon total number of trials. Total number of trials. Clear? And there is a condition here. Here you must remember that M may be 0 or greater than 0, but it will be less than equal to n. This is the condition. Clear? If you divide or you can say here 0 is less than equal to M is less than equal to n. If we divide by n, so 0 upon n less than equal to M upon n equal to n upon n. 0 divided by n is 0. It is M upon n. M upon n means PA or PE is less than 1. So the empirical probability is always lies between 0 and 1. Clear? You must remember this. This property I am again proving how we are getting it. Probability is always lies between 0 and 1. Clear? Now we will solve some questions here on the basis of empirical probability from your book. And the question here is, example here is that a player has made 527 free throws in 698 attempts. So how many total attempts he made? He made 698 attempts. And how many made free throws? It was 527. Clear? Then the probability that the player makes a free throw, clear, on the next attempt is equal to. So what is this? This is the past, that out of 690 attempts he made 527 free throws. So now he is asking the future, that the probability that player makes a free throw on the next attempt, how much it will be? Clear? That you need to find. Clear? Then find the probability. Clear? So what will do it here? Let E is the event that the player making a free throw is the event, and if he is the event, then the probability of E is equal to how many he made? He made 527 free throws out of how many? 698. So 698 are the total attempts. How many favorable? Favorable means he is asking about the free throws. So we are talking about this favorable 527, and if you will calculate it, it is approximately 0.76. Clear? This is about the empirical probability, where we are now 0.6. 0.6 means if you will change this 0.6 it will be changed into 0.76 multiply by 100, it will change into percentage. So it is 78% chance, clear, that the player is making a free throw. 78% chance. So on the basis of this previous data, past data, we can say that the future is 78% chances. Okay, now there will be another question. What is this? In 2002, there were 62,318 flights departed from Muscat International Airport. Clear? This is. And out of 600,318 flights, how many? 8,821 were late. Were delayed. Clear? So, find the probability. That the next flight from Muscat International Airport will be late. This is clear. So what we will do, let E is the event. Let E is what? The flight is late or delayed. E is the event. Then probability of E is how we are getting total flights and the late flights. How many late flights? 8,821. And how many total flights? It is 62,318. And if you will calculate it, it is 0.14. Clear? If you multiply by 100, you can change it into percent. So 14%. Probability is 0.4. Clear? But in case of percent, 14%. So probability, there are two things we can conclude. Probability that flight will be late is 0.14. This is number one conclusion we draw. Or another is 14% flights from Muscat Airport are delayed. You can conclude this. Clear? So this was the past data, 2002. Out of these flights, these flights were late. Now we are concluding that the next flight will be right time or delayed. So that we conclude it 0.14 is the probability that the flight is late. Or another conclusion we can draw is 14% flights from Muscat Airport are generally delayed. Clear? So this is the question. Clear? So you need to be you need to think about it that whenever past data is given and we are asking about the future event, clear, then it is empirical probability. Okay, so the one more question we will evaluate, we will study one more example, and that example is on the basis of frequency table. Example based on frequency table. Based on frequency table. What is this? Consider the table. Consider the table. What is the table? Okay, this is class that we study in statistics, and here is the frequency. Frequency is denoted by F. So class is 90 to 99. What is the frequency? The 4. Then 80 to 89. The frequency is 6. Then 70 to 79. The frequency is 4. 60 to 69. The frequency is 3. 50 to 59. 2. And 40 to 49. The frequency is 1. This is the database given in the question, that there are some classes and the frequencies are given. Now they are asking some questions. What is the question number 1? We will start question number 1 here. Find PA. You need to find PA. What is A here? A is the event. A is the event of getting scores between 90 and 99. Clear? In the exam. So this data represents the exam, that how many students got 90 to 99 marks? 4. How many 80 to 89? 6. How many 70 to 79? 4. How many 40 to 49? Only 1 student. Clear? So what is the total frequency you need to check? So how many total number of students? So if we check the total number of students, it is sigma F, total number of students, 6 plus 4, 10, plus 4, 14, 3, 17 to 19 and 120. So total frequency is 20. Okay, so if A is the event of getting a score between 90 to 99, what is the probability? Probability of A is, what is PA? Total students and the numerator means favorable. How many total favorable? So number of student getting a score between 90 to 99. So how many students are getting a score between 90 to 99? It is 4 only. So answer is 4 upon 20. Clear? And 4 upon 20, if you will divide, it is 0.20. Clear? So this is how we evaluate the probability. Now we will take question number 2. What is the question number 2? Question number 2 is find PB. You need to find PB. What is B here? B is an event of getting scores between, not between, getting scores less than 70. Less than 70. Clear? So if you see here, what is PB? PB is total students And what is above? Number of students. Students getting scores less than 70. Clear? Less than 70 means it is above 80 here. Less than 70 means here. So 4 plus 3, 7 plus 2, 9 and 1, 10. It is 10 upon 20 and it is 0.50 if you calculate it. Clear? Less than 70 score. Less than 70 score means, oh no, this is wrong. We have done wrong. What wrong we have done? Because less than 70, it is above 70. Less than 70 is here. Less than 70 is here. It is above 70. I'm sorry. So it is 3 plus 2, 5 plus 1, 6 upon 20. And it is how much? 0.30. This is the probability. Clear? Now another questions also, there are 4 parts in this question. So if we see the third part is find PC. Clear? What is C here? C is an event. C is an event of getting scores between 80 and 89. So PC equals to total students and here is number of students getting scores between 80 to 89. And how much it is? 80 to 89 we need to check in the previous slide. 80 to 89. It is how many? 6. So total students are 20. So 6 upon 20. And 6 upon 20 is how much? It is same 0.30. And the last question here is find PD. PD. What is this? Let E is the event. Let D. E, not E, D. D is the event of getting scores between 70 to 99. 70 to 99. Clear? So PD equals to, it is total students and number of students between 70 to 99. Now we will calculate. Total students are 20 and 70 to 79. We will check from the table. 70 to 99. It is this much of a student. 70 to 99. So it is 6 plus 4, 10 plus 4, 14. So this is 14 upon 20. And 14 upon 20 is 0.70. This is clear. So that's all about the empirical probability. In the next lecture, we will learn about the classical probability, and there you will have so many questions to solve. Okay, so thank you very much for attending this lecture.